We think of great whites or orcas as the pinnacle of marine terror, but compared to deep history, today's ocean predators are quite tame. For hundreds of millions of years, the ocean was a ruthless evolutionary battleground. Survival required specific, aggressive adaptations, forcing species to engineer biological weaponry just to maintain their place in the food chain. This timeline curve charts an escalating arms race over 500 million years. Predator sizes surge upward, only to hit sharp drop-off points. These mass extinctions were ecological resets, clearing the top of the food chain to restart the cycle. To understand how biology builds a successful killer, we have to look closely at the specific environmental pressures that force these animals to adapt. Let's go back 500 million years to the Cambrian period. The oceans back then would look entirely alien to us, packed with an explosion of highly diverse life forms. But almost everything swimming around was tiny. Most animals were about the size of your fingernail. Then came Anomalocaris. In a world of microscopic prey, this 3-foot-long predator was a physical giant, making it the planet's first true apex killer. It hunted using advantages that had never existed before. It possessed complex compound eyes to spot targets in murky water, and used spiked, grasping appendages to snare and crush its prey. The sudden arrival of a highly efficient hunter left every other organism with two options: develop a defense or go extinct. That single evolutionary leap ignited the marine arms race. Fast forward to the Devonian period, 360 million years ago. To survive the Cambrian hunters, prey animals developed heavy, literal bone armor across their bodies. The evolutionary response to heavily armored prey was an even heavier, armored predator, Dunkleosteus. This mechanical breakdown of a Dunkleosteus skull reveals a unique adaptation. Instead of teeth, it had massive, exposed, bony plates. As the jaw opened and closed, these plates constantly ground against each other, creating a self-sharpening mechanism. Look at how the force distributes as those plates snap shut. Dunkleosteus generated an immense bite force, easily capable of slicing contemporary, heavily armored sharks completely in half. But even with extreme biological armor and a devastating bite force, this lineage was not immune to planetary change. Environmental volatility eventually triggered another mass extinction, proving that specialization alone cannot beat a changing climate. By the time we reached the Mesozoic era, the strategy had shifted. While dinosaurs dominated the land, a completely different lineage, marine reptiles, took control of the oceans, prioritizing speed and sheer scale over heavy armor. This era introduced the pliosaurs, often referred to as Predator X. These reptiles were built for unstoppable, torpedo-like speed, driven by 4 massive flippers and equipped with skulls the size of small cars. Yet even the pliosaurs were eventually outcompeted by a newcomer that traded massive bulk for extreme maneuverability, the mosasaur. This anatomical cutaway of a mosasaur's mouth highlights exactly why it was so deadly. Reaching lengths of 50 feet, it featured a snake-like jaw that could unhinge to swallow massive targets. Further back in the throat, it possessed a secondary set of palatal teeth designed specifically to hook into prey and drag it inward. This specialized anatomy made mosasaurs so effective that they quickly spread across the globe. They hunted almost everything in the water, including other smaller mosasaurs. The mosasaur succeeded by combining extreme scale with jaw mechanics that allowed it to systematically consume almost any biomass in the water. When an asteroid impact 66 million years ago wiped out the marine reptiles, it created a massive ecological vacuum. Mammals eventually entered the ocean to fill it, evolving over millions of years into large, blubber-rich whales. And nature produced a highly targeted evolutionary response to hunt those whales, the Megalodon. To take down prey this massive, the Megalodon reached 60 feet in length, carrying jaws lined with multiple rows of serrated teeth, each the size of an adult human hand. This force impact visualization illustrates its hunting strategy. Instead of just biting soft tissue, the Megalodon specifically targeted the thick rib cages of prehistoric whales. It generated enough compressive force to completely crush the bone and forcefully rupture the animal's internal organs. By the Pliocene, the megalodon had pushed the predatory shark body plan to its largest physical scale, outsizing any other marine hunter in the fossil record. So why are these 60-foot hunters no longer patrolling our oceans today? The answer lies in the climate. An incoming ice age caused global sea levels to drop significantly, and ocean temperatures plunged. The whales adapted to the drop in temperature by migrating into freezing polar waters. The megalodon, heavily reliant on warm coastal waters to maintain its massive cold-blooded metabolism, couldn't follow them and starved without its primary food source. Today's oceans are relatively quiet, composed of specialized, localized ecosystems that favor efficiency over the sheer, violent gigantism of the past. But the ocean remains a continuous engine of adaptation. Biology will always respond to the pressures of its environment, which means the next massive shift in the marine arms race is simply waiting for the next major climate transition.